So we're going to look at the sum of this series. So there's a number of ways to look at this, but whenever you have a difference, one thing to think about is going to be think about this in terms of a telescoping series. In other words, we're going to write out the nth partial sum, and we're going to see that some of the plus terms are going to cancel, or a lot of the plus terms are going to cancel with a lot of the minus terms. Okay, so we're going to write this as, if I want to look at the nth partial sum, I'm going to have k equals 1 to n cosine 1 over k minus cosine 1 over k plus 2. And I'm just going to come down. I'm going to need a lot of room to say what this is equal to. Okay, so when k is equal to 1, I'm going to have cosine of 1 minus cosine of 1/3. This is k equals 1. Okay, when k is equal to 2, I'm going to have cosine of 1/2 minus cosine of 1/4. This is what happens when k is equal to 2. Okay, when k is equal to 3, it'll be cosine of 1/3 minus cosine, I need to squeeze this a little, minus cosine of 1/5. And we can kind of see what's going to happen. Like this minus 1/3 is going to cancel there, but the minus 1/3, or sorry, the 1/2 isn't going to have anything to cancel with, for example. And then so plus, and now we'll see what happens when k is equal to n minus 1. We're going to have cosine of 1 over n minus 1 minus cosine of 1. Okay, if k is equal to n, if k is equal to n minus 1, n minus 1 plus 2 is going to be n plus 1 plus cosine, this is going to be k is equal to n cosine 1 over n minus cosine 1 over n plus 2. Okay, so now let's see what's going to happen. So the cosine of minus 1/3 here is going to cancel with this cosine of minus 1/3. The cosine of 1 doesn't have anything to cancel with. The cosine of 1/2 doesn't have anything to cancel with. Now, the cosine of minus 1/4, the next term there's going to be a plus cosine of 1/4. So this is going to cancel with something there. Okay, and similarly, the cosine of 1 over n minus 1, or let me look at the cosine of 1 over n. So the previous subtract term is going to be minus cosine of 1 over n, so that's going to cancel. And then the one before that, and then the one before that, cosine is going to be plus or minus cosine of 1 over n minus 1. So these two terms get canceled. Okay. If you don't quite follow this, do this sum like when n is equal to 5 and see what gets canceled. Do it for like n is equal to 5 and 6, and you'll see that what happens is that the only terms that don't have something cancel will have the first two terms over here. We'll have the first two terms over here, and then the last two terms over here. Or sorry, the first two adding terms and the last two subtracting terms. So this is cosine 1 plus cosine 1/2 minus cosine 1 over n plus 1 minus cosine 1 over n plus 2. Okay, and so in general, so notice that there's like a difference. So here we have k, this is k plus 2. The difference is 2. In general, this is what's going to happen. Like if this was 3, it'd be cosine 1 plus cosine 1/2 plus cosine 1/3, and then we'd have the last three terms here. Okay, so now what's going to happen then? The limit as n goes to infinity of Sn, so let's think through this. Cosine 1 and cosine 1/2, those don't depend on n. So that's just going to be what it is, cosine 1 minus cosine 1/2. Okay, now cosine is continuous. The limit of 1 over n plus 1 is 0. The limit of 1 over n plus 2 is 0. So it's going to be minus cosine 0 minus cosine 0, but both of those are equal to 1. So overall, this is cosine 1, this is plus cosine 1/2 minus 2. And that is the final answer. And again, we computed it by using the telescoping series and fundamentally computing what the nth partial sum is and taking the limit of that as n goes to infinity, because that is what the definition of the sum of a series is. It's the limit of the partial sums.